Now, as mentioned yesterday, today what we're going to talk about is killing fractions, which is going to be a trick that's going to be very helpful all the way through Algebra 2, maybe even into trig. The kill fractions objective is 84. It says, solve equations multiplied by LCD, which is least common denominator. But what I'm calling it is the kill fractions objective. So we're going to see lots of fractions on this, but we're going to learn, because fractions are not user-friendly, we're going to learn how we can kill them and make problems simpler. So here's the gist of it. When every piece of an equation on both sides, the left side and the right side, and you know what pieces look like. They're separated by what? Pieces of an equation are separated by minus or minuses or pluses. So when every piece of an equation on both sides is a fraction with the same denominator, what we can do is we can cross out the denominator. And essentially that would be killing fractions. You have to ignore my crazy handwriting there. But when every piece of an equation is a fraction with the same bottom, what we can do is cross the bottoms out. That's what we're trying to say up here. So I'm going to look at a few easy ones to start with. Alright, here's an equation. Now, how many pieces are in this equation? Three pieces. This piece, and that one there. Is this a fraction?
Yes.
Is this a fraction?
Yes.
Is this a fraction?
No.
No. So the very first thing you do is go, okay, look at the fractions, and they look ugly, they look hideous, and you want to kill them because doing problems with fractions is no good. And fractions are scary. So the first thing we do is look at the 4.
Put it over 1.
And we have to make it a fraction. So before you can do kill fractions method, make the 4 a fraction by putting it over 1. You're not allowed to put anything else on bottom other than a 1 right there. So now they're all fractions. It's like you got to make it worse before you can make it better. So make the last thing that's not a fraction a fraction. Now what we want to do is look at the bottoms of all 3 pieces. You have a 3, a 9, and a 1. We want to be able to get them all to be the same. So is there some number that looks like we can make them all become? 9. We can make this 3 become a 9 if we tripled it. That 9 is a 9, so leave it alone. And we can make a 1 become whatever we want it to be. So here's how we get this 3 to become a 9. You can't just change a 3 to a 9. It can't become x over 3 and then magically you want it to be x over 9. What you do is put 3 over 3. We're going to multiply this piece by 3 over 3 because 3 over 3 is a fancy way to write the number 1. So I'm going to multiply this by a fancy 1 because I want 3 over 3 to make 9. And I'm going to multiply this by a fancy 1. I'm going to put 9 over 9 right here. Or on this side, 9 over 9. And I'm going to leave this one alone. It's already got a 9 on bottom. It's good. It's ready to go. So this makes 3x over 9 plus x over 9 equals 36 over 9. Now, is every piece of your equation a fraction?
Yes.
Does every piece have the same bottom?
Yes.
They're all 9s. If every piece is a fraction, I mean every piece, there's 3 pieces and they're all fractions, and every piece has a 9 on bottom, you are allowed to kill the fractions by crossing out the bottoms like they didn't even exist. And so now the problem really becomes much simpler. It's just 3x plus x equals 36. That is way simpler than what this is. And these will get even, this is not even the ugliest one you're going to see. They'll get even uglier, but you can make them way simpler. So 3x plus x makes how many x's? 4x. You got 4x 36. And then that 4 is a coefficient. And how do you get your coefficient off for your letter? Divide. Divide both sides by 4. And x equals what? 9. And that's it. So remember how we do the kill fractions. First thing is, if you have a piece that's not a fraction, what are you supposed to do with it?
Put a 1 underneath them.
Put a 1. You're not allowed to put anything else under it but a 1. So if it's not a fraction, put a 1 under it. And then we've got to make all the bottoms become the same. So that's what we are going to do a couple times on the back side here. All right, this is identical, not that one, this one. Identical to what we just did. So I got x over 5 minus x over 8 equals 9. First, if I'm going to kill fractions, I got to look and see, do I have one piece that's not a fraction?
Yes, 9.
It's 9. So I got to make it a fraction. So what do I got to put on it?
9 over 1.
9 over 1. So the first step of kill fractions is make it worse before you make it better. Make that last piece fraction with 9 over 1. Now look at your bottoms. A 1, an 8, and a 5. Unfortunately, I can't just make this 5 multiply into an 8 very easily. So I've got to change them all. What is the magic number I can make all these bottoms become?
40.
40. If you don't know what it is, well, look at the 5 and 8, and 5 times 8 is 40. So I can make a 5, I can multiply 5 up to a 40, I can multiply an 8 up to a 40, and I can multiply 1 up to whatever I want it to be. So, when I look at the 5, what do I got to multiply 5 by to make it 40?
8.
8. So I have to put an 8 over 8, because that's a fancy 1. What do I got to multiply 8 by?
5.
So I'm going to put 5 over 5, that fancy 1 again. And then what do I got to multiply 1 by?
40.
40 over 40. This is the most missed part of it, is that you have to multiply the 1 by, got to go 40 over 40. So this turns into 8x over 40 minus 5x over 40 equals, I think it's 360
It is.
over 40. Now, in your equation, is every piece a fraction? Is everything have the same bottom?
Yes.
So then cross the bottoms out. You got 8x minus 5x equals 360. So it's like these aren't there. 8x minus 5x is 360. So combine your x's. What's 8x minus 5x?
3x.
3x.
3x equals 360.
Divided by 3.
Divide by 3 and x equals what?
120.
120. X equals 120. These are kind of the simpler examples. The next one kind of still simple. Now you got x over 2 plus 6 over x over 2 plus 6x over 7 equals 19. We're going to kill fractions. What's the first thing we got to do before we go into our kill fractions?
Put 19
Make them all a fraction.
Yeah, 19 is not a fraction. 19 needs to become a fraction so I can use the kill fractions method. All right, I've got a 2, a 7, and a 1. What's the best number I can come up with? 14. It's the best number I can come up with. So what am I going to multiply this first piece by?
7.
7 over 7. I got to go 7 over 7. Then the second one needs what over what? 2's. 2's over 2's. And lastly, that 19 over 1, I need to go 14. All right, so this is 7x over 14 plus this is 12x over 14 equals 266 over 14. Everything is a fraction. Everything has a 14 on bottom. So what does that mean? Cross them out. Kill the fractions. Fractions are dead. So they're not there. They're gone. Alright, then put your x's together. You got 7x and 12x. So how many x's is it up? 19x equals 266.
14.
Divided by 19. And you tell me it's 14? It's equals 14. 14 was a real special number in that one then. 14. Okay, these last two get complicated, so give extra attention on these last two. And ask questions if you get confused. There's some monsters in this. Okay, when you look at this question, this one's like a monster. It's a big mess, but it's one piece. We've got one piece, 2 pieces, and this ugly third piece. Now they are all fractions right now, aren't they?
Yeah.
So you don't have to put any over ones. But here's what we need to do. 7, 35, and 70. So what's the best we can do? 70. So the good thing on this one is you get to leave the monster alone, and we're going to end up killing that bottom. So let's go, how do you get that to be 70?
10.
10 over 10. How do you get 35 to be 70? 2 over 2. And leave the 70 alone.
Oh.
Leave the 70 alone. So we end up with 50 over 70 minus 2x over 70 equals 2x plus 1 over
2x plus 11.
2x plus 11 over 70. All right, everything is a fraction. Even the monster is a fraction with a 70 on bottom, so cross the 70s out. And now it goes from being a nasty looking ugly equation to being something a little more manageable. You got 50 minus 2x equals, and I'll go ahead and distribute that, 2x plus
22.
22. So cross the bottoms out, and that's what we have. Now we've got to work it out. This is an equation, though, where you have x's on both sides, so it's a little more difficult. When you have x's on both sides, what did we say we're going to do?
Subtract 2.
Get them on the left side.
Yeah, let's get them on the left side. So the one over here on the right needs killed, and you're going to kill a 2x by...
Add.
Minus.
It's,
Subtracting.
yeah, it's plus 2x right here, so it's minus 2x.
I always just do the one that's not a negative.
And
If it's a
that's
negative,
fine,
I
too.
add 2 to the other.
And that's, you'll still get the right answer. I was just saying the general rule, we kind of want x on the left as it goes.
I just do it straight.
Okay, so you have 50 minus 4x equals 22. Then what needs to go next?
Subtract. Add 50
Yeah,
plus
this is your x piece, so
subtract 50.
subtract 50. Why are we subtracting 50?
So you
Because
get
it's a positive.
Yeah, it's
Negative
positive 50.
28.
I want to kill positive 50 with negative 50. And I end up with,
28.
yeah,
A is x equals 7.
negative 4x equals negative 28. And then divide both sides by negative 4.
And x equals positive 7.
X equals positive 7. So we get x equals positive 7. And the last one, now that I corrected the one mistake on the notes, I think we should be able to do it. So make sure that you have x plus 1 right there. Okay, same thing though. You've got 3 pieces, one of them's a monster, but before you can start this, you got to put a 1 underneath the 8. You got to take a step back. You got to make it worse. You got to make them all fractions. So now they're all fractions. 1, 5, and 11. What's the best we can do with a 1, 5, and 11?
55.
55.
55. 55 is the best we can do. Which means you're going to have to mess with the monster. We'll get there though. Start with what over what?
55 over 55.
55 over 55. So we'll start with 55 over 55. So 55 over 55. And then what goes right here?
11 over 11.
11 over 11. And then this one, 5 over 5. Alright, so you end up, what is 55 times 8?
440.
So you got 440 over 55 minus 11x over 55 equals. Now on this one, and here's the hardest part of it, is knowing what to do with this. Last time we didn't have to tweak the monster, but this time you do. Just multiply your 5 and 6 together and make it 30,
That's it.
and then we'll distribute it next. So make it 30 times x plus 1.
30x plus 30.
30x plus, yeah, that's what it's going to be. It's right now it's 30 times
Oh.
x plus 1 over. So when you're multiplying this by 5 over 5, that becomes 55, and that becomes 30 times x plus 1. And then let's cross the bottoms out. And then you have a little bit easier problem. You got 440 minus 11x equals 30x
Plus 31.
plus 30. 30x. 30 times 1 is
Oh.
30. We're multiplying there.
Oh, yeah.
Distribute. Okay, so x is on both sides. What are you going to do about x is on both sides?
Subtract
Subtract which one?
the right side.
Yeah, let's kill the right side. Not necessarily, I mean, if you did the other way, you'll still get the right answer, but let's just in general be on the same page. So I've got 440 minus 41x equals 30. I'm coming down here onto the sticky note. What are we going to do next?
Subtract the 440.
Yeah, I'm going to kill the 440. And I got negative 41x equals negative
410.
410. Divide both
by
sides
negative
by.
41.
And this should come out nice and even. X equals positive what?
10.
X equals positive 10. Okay, so if you see fractions in the equation you're working, and you want to kill them, what's the first thing you need to make sure of?
All their fractions.
all fractions. So anything that's not a fraction, what has to go under it? A 1. And then our goal is to get the bottoms to do what?
Match.
To be
The same.
the same. And if they're all the same, what are you allowed to do?
Cross them out.
Cross them all out. So put a 1 under any non-fraction, get all the bottoms the same, and cross them out. And then you should be able to work it from there. You'll make an easier problem. And that is it. That's the kill fractions method. It's going to take a little practice, but it will help you out in the long run knowing how to kill fractions and making problems easier.